Alright, well, good morning, good afternoon, good evening, whenever you're watching the videos. It's, well, good to have you here. Welcome. We're taking a look at 6.1. Chapter 6 is polynomials factoring, and Chapter 6.1 is talking about a couple different things. We talked about 6.1a, talked about a couple different things, including factoring, greatest common factor. This one talks about, this section, this video talks about factoring out a binomial factor right here. And then factoring by grouping. We'll use factoring the binomial factor inside of factoring by grouping, so we kind of have to look at this topic first before we do anything more. So let's take a look at stuff. So here is now what we're going to do. We are going to use, I guess, these two here. We did, this is A up here, this is B down here. We're going to factor by binomial factor, and then factor by grouping. So we're going to fast forward through all the stuff that we've done before. Here's factoring by an outer negative factor. There's the question for your homework for the previous one, and here we are. We're now factoring out a binomial from a polynomial. So what we need to do is we take a look at this. This is our polynomial. We have to say we're going to try and factor out the greatest common factor from this polynomial. In order to do that, we have to find out what the greatest common factor is between this term, remember terms are separated by addition, and that term. I don't know how I got that. Alright, it should be blue, but it's colorful at least. Alright, so let's make it blue anyway, just to make fun. Just to make it consistent, there's blue. Alright, so now we've got to find out what the greatest common factor is between the green and the blue. What should be the blue? What's the greatest common factor? Well, we look at the coefficients or the numbers. 2 and 5, nothing common there. Another factor from the green one would be W, because all these things are multiplied together. There's a factor there as W. Any W's over here that we can factor out? Nope, nothing there. Alright, well, the next thing is this factor here is an x plus 3. Right there is x plus 3, right there is x plus 3, and it's a factor in each one of them, so it could be a greatest common factor. So our greatest common factor then should be x plus 3, because that binomial is in each one of these factors in the polynomial. Here's our big polynomial here. X plus 3 is a factor, so what is our factorization? X plus 3 can be pulled out, can be factored out of each of these terms, and if we take our steps, I guess, determine what is the greatest common factor. Step 2 is rewrite everything in terms of the greatest common factor and something else. So this could be x plus 3 times 2w minus x plus 3 times 5. And 5 times x plus 3 is the same thing as this blue rectangle. 2w times x plus 3 is the same as this green rectangle. So we've kind of just taken a step and said, well, let's pull it out into the front part of each of the terms. And now we can go use the distributive property kind of in reverse and say, well, it should be x plus 3. The next factorization would be x plus 3 times whatever's left, 2w minus 5. So our factorization would include x plus 3. X plus 3 becomes our factor right there that we've pulled out using the distributive property. What's left? 2w minus 5. Right there, 2w minus 5. Alright, that said, let's go through that one. You guys can, I'm gonna ask you to pause the video, work through this one yourself, and we'll see what kind of answer we get. Alright, so for this one, we have to again factor out a binomial from a polynomial. Do we have any binomials from a polynomial? Here's our big polynomial. The whole thing is a polynomial. Here's a term here, here's a term here. In order to factor out the greatest common factor, we have to look at all the factors of each term and factor out the greatest common factor. Is 8 a greatest common factor, or anything of 8 a greatest common factor? Well, 8 is made up of 2 times 2 times 2, so it'd have to pull out a 2 if we pulled something out, but there's no 2's in 9. 9 factors to 3 and 3, so there's nothing to pull out there. There's a y here, and there's no y's over here, so the only thing we can really pull out is the a plus b from each of the terms. Here's a term here separated by addition or subtraction from this term here. This is a factor. A plus b is a factor of this term. A plus b is a factor of this term. So we can now choose to rewrite each term in terms of that greatest common factor and what's left. So again, I'm just rewriting each of the terms in terms of a plus b as the greatest common factor and what's left. So 8y times a plus b is the same as this. A plus b times 9 is the same as 9 times a plus b. So really we've just factored it out and said, well, I'm going to rewrite this in terms of my greatest common factor and what's left. Here's my greatest common factor, what's left. Here's my greatest common factor, what's left. And now we can use the distributive property to say, well, let's pull out that a plus b as our greatest common factor, and then rewrite everything that's left, 8y minus 9. And there's our factorization, including factoring out this greatest common factor that happens to be a binomial. So we're going to use this idea of factoring out a binomial out of two terms of a polynomial later on when we do factoring by grouping. Alright, so let's get to factoring by grouping. So you know what, earlier on, let's before we get to factoring by grouping, let's talk about FOIL. When we FOILed something, that's that dreaded F word. We took the first term, we multiplied the first terms, and a times c gives me ac. And then the outside terms, a times d gives me ad. And then the inside terms, b times c gives me bc. And then the last terms, b times d gives me bd. So now, if we are given, so knowing this, if we are given AC plus AD plus BC plus BD, which is really just this, if we're given that, we have to factor things out. With a 4-term polynomial, a lot of times we can factor that by factoring by grouping. So if we factor these two together, in other words, these first two terms together, AC and AD, we can group those together and see what we can factor out of that. And then we can also factor, or I guess group, BC plus BD as one group, and then factor out an A from here. We'd get an A, oops, hang on, let me change the green here. We'd get an A as the greatest common factor here. What's left? C plus D. And we would factor over here as well, and we'd factor out the greatest common factor of B times C plus D, and we could take the intermediate step of writing this as B times what's left over C plus B times what's left over D, and then going through and factoring that out. But it's kind of easier to see it, or just as easy to see it, as factoring out the B from each of these terms. And then we've got a greatest common factor. Now we've got a greatest common factor of C plus D. C plus D, we can pull that out of this term and this term, just like we did back here. We pulled out the A plus B as a greatest common factor and became A plus B times whatever's left over. Now we pull out the C plus D. C plus D is over here, and what's left over? A plus B, which is really what we started up here, A plus B times C plus D. A plus B times C plus D. And it doesn't matter that this one is, whichever one is first. When multiplying, it doesn't really matter that 2 times 3 gives you 6 or 3 times 2 gives you 6. So what we're going to do is take something like this and factor by grouping. Here's the green one, here's the blue one, and factor by grouping, and factor out a greatest common factor, and then factor out from these two terms the greatest common factor that happens to be a binomial. Alright, so that said, let's work on this one. Let's work on the blue one. Hang on a second. Don't know why this changed to purple. Here's blue. There's my polynomial that I want to factor, and it happens to be 4 terms. If there are 4 terms, I recommend taking a look at factoring by grouping, because it might be able to help. In fact, I'll tell you that if there are 4 terms, factor by grouping. So if we're going to factor by grouping, I'll use blue here, and I'll say my first factor is going to be, or my first grouping would be these 2 terms here. My second grouping will be these two terms here. So let's factor the first two terms. What's the greatest common factor between 3ax and 12a? Well, it has to be a 3, and it also has to have an a in there. So if 3a is my greatest common factor, then I'm going to rewrite it kind of like this. So I can say 3ax divided by 3a gives me just x, plus 12a divided by 3a gives me 4. And if you need to, you can go up here and do an, kind of do an aside, do a little side note and say, well, it's 3ax divided by 3a. 3's cancel, a's cancel. As long as a is not equal to 0, that gives me x, and that x goes right there. Same thing could hold true for the 12a or any other division that you're going to do later on, or factorization you're going to do later on. Let's see. You know what? I think probably what's going to make it easier as well is going to put that plus inside inside of the grouping. That'll make it a lot easier. All right. So now, what is common between 2bx and 8b? Well, it would be 2 plus 2 times, and plus 2b. There should be another b as well, because a b is common between this term and that term. It's a b is a factor here, and b is a factor here, so it could be a greatest common factor. In fact, it is part of the greatest common factor. Be careful when you write the b. It has to look like a b and not a 6. This kind of looks like a 6, but it should be a b. Plus 2b. Now what's left over? 2bx divided by 2b is x, plus 8b divided by 2b gives me just 4. And now the nice thing is, if you've done this correctly and it's factorable, then x plus 4 and x plus 4 become common factors out of these two terms. Here's a term here, separated by addition from this term here. What's the greatest common factor? Here's a factor. X plus 4 is a factor. X plus 4 is a factor. So we can now factor out x plus 4 and rewrite it, or I guess write what is left over. I've got 3a plus 2b. And there's my factorization. So this, all these four terms together, factored into x plus 4 times 3a plus 2b. And we could double check our work by foiling this, but this red box is going to be exactly the same as this blue box. Alright, I'm going to ask you now to pause the video, work on this one by yourselves, and say, what kind of factorization do I get out of that? Number one should be to group some terms, group the first two terms, group the second two terms, pull out a greatest common factor from the first two terms, greatest common factor from the second two terms, and then see if there is a binomial that can be pulled out of each one, that can be factored out of each of the next two terms, each of the two terms that you get down here. Alright, pause the video, do some work. Alright, so let's work on this. Alright, group those two together. Group these two together. So if we see a 4-term polynomial, we can factor by grouping. If we see a 4-term polynomial, we can factor by grouping. So if we are factoring by grouping, let's take a look at these two terms in this grouping and see what kind of greatest common factor we can pull out. For this, you could use the cake method, but it's just as easy to say, well, there would be a 5 as a greatest common factor in terms of the coefficients, the numbers. Would there be an x? Well, there can't be an x because there's no x over here as a factor in this term. So we have just 5 as the greatest common factor. So it would be 5 times x. Again, this x is 5x divided by 5. There's a plus sign. 10y divided by 5 gives me 2y. And we can double check that by saying 5 times x, kind of use the distributive property now. From here to here, we use the distributive property in reverse. From here, in our factorization, to get back up here, we can use the distributive property to kind of double check. 5 times x is 5x. 5 times plus positive 5 times positive 2y gives me positive 10y, and there, we've done a good factorization. All right, so let's switch to green and start factoring this. What's the greatest common factor? Well, there should be, let's see, coefficients, any coefficients? There's a 1 here and there's a 2, so the only greatest common factor would be a 1. There's no need to write a 1 as a greatest common factor, so we go to the variables. A, is there an A in each one? Yep, there sure is. So I'll write down a plus A. And then is there, and that's the highest exponent that we can pull out of as an A to the first power. There's an x over here. Is there an x over here? Nope. So now we're pretty much done with this factor, so there's nothing else to pull out then. So what's the factorization? Ax divided by a gives me x, plus 2ay divided by a gives me 2y. And there's my factorization of the green. We can double check it by saying a times x gives me ax, a times 2y, both positive gives me a positive 2ay, and yes, our factorization over here in the green is correct. And now we can say, we can look at our this line here and say, is there anything common in this term and that term? Because now we've got really just a polynomial that's a binomial, because here is a monomial, a 5 times this factor, and an a times this factor is this term in green. So what is common? X plus 2y and x plus 2y factors out. That can be factored out of each one of them. Here's my x plus 2y times what's left over, 5 plus a. And there's our factorization. We could double check that by foiling it out to make sure that we've got all this product here, all these terms here, but we can. So first terms would be x times 5 gives us 5x, so that one checks out. Outside terms, x times a gives me ax, and that's okay. Inside term is 2y times 5 is 10y, and that's right there. And the last term, 2y times a, is 2ay, and that's right there. So sure enough, this multiplied out gives us our original polynomial. All right, so if you see 4 terms, factor by grouping. Let's take a look at this one. In fact, this should be our last question. So this header, I don't know why this, oops, hang on a second. Okay, so this header here includes the idea of a negative factor, and I'm going to give you the hint that, because this will be your homework. Remember, you're taking notes, you're writing down the notes. In your notes, you're going to do the one of the factors as homework to make sure that you've done it and you've kind of looked at the video and you have any ideas about it, and you can work some of the questions. So this is your homework assignment to get into class. Included in your homework, and the picture of your homework should go to my Dropbox. I'm going to give you a hint that the negative factor sometimes has to be pulled out. So our steps here are, well, I tell you what, we've got a 4-term polynomial. If we've got 4 terms, maybe we can factor by grouping. But in order to really factor by grouping, factor out a negative 1 from the leading term, factor out maybe a greatest common factor from all 4 terms. If there is anything from all 4 terms, it'll make your life easier. And sometimes we have to figure out, you have to factor out a negative factor to make this binomial the same as that binomial, to make this binomial the same as that binomial, because if these are different, you can't factor it out as the x plus 2y. If this were x plus 2y and this were negative x minus 2y, you couldn't factor it out because it wouldn't be the same thing. So that said, there's a hint to factoring out a negative factor maybe here and maybe here too. All right, so that said, factor out a negative 1 from, if you see 4-term polynomial, factor out a negative 1 from all terms. Factor out a greatest common factor. Oh, by the way, there's a hint as well, from all 4 terms to make your life easier. And then for this one specifically, see if there's a negative that can pull out. All right, any questions? Bring them to class, work on this. Refer to the book if you need, and we'll see you soon.